The Shroud of Turin is one of the most well-known and most hotly contested of all Christian relics. The idea of a physical artifact which directly attests to the miraculous resurrection of Jesus poses a serious problem for anyone who believes Jesus was just some good teacher or perhaps didn't even exist at all. For that reason, many people find just enough evidence to support their desire for the shroud to be a medieval artistic forgery and consider the case closed. In fact, most people aren't even in a proper intellectual position to evaluate the evidence for the shroud, because for someone who has already presupposed that God doesn't exist and that Jesus was not raised from the dead, the only available option for the shroud is forgery. But if you're ready to approach the question objectively, remaining open to its authenticity and all of the worldview implications that accompany it, then join me as we dig into the evidence for the authenticity of the Shroud of Turin. For those not fully informed, let's first quickly review the basics on the Shroud of Turin. It's a piece of fabric made from linen threads. If you're not aware, linen comes from fibers of the flax plant. The threads are sewn in a 3-to-1 herringbone weave. The shroud is approximately 14.5 feet long by 3.5 feet wide. On the cloth are what appear to be bloodstains and a faint image of both the ventral and the dorsal sides of a man. You can imagine a man lying down on one side of a cloth with his feet toward the short edge, and then folding the cloth over his head to cover the front of his body. When the shroud was first photographed, the photographer developing his negatives discovered that the image of the man is essentially a photographic negative itself. This means that if you invert the colors of the photograph, the image becomes a photographic positive and significantly more discernible. The image itself contains three-dimensional information in the form of a shaded depth map. The image is darker in areas of protruding features like the nose and the chin, and lighter in areas of sunken features like the eye sockets and the sides of the head. Loading this information into modeling software results in a clear, three-dimensional image of the man. The Shroud of Turin gets its name because of its current home in Turin, Italy, where it's resided since 1578. It was first given to the House of Savoy, who resided in Turin, in 1453 by Margaret de Charnay. The first widely accepted owner of the shroud was Geoffrey de Charnay, and the shroud was known to be in his possession around 1350. There is no documented account of how Geoffrey came into possession of the shroud, though a plaque in a church on his land in Liry, France, says he received it as a gift from the King of France for his valor in battle. However, most people do not believe this story to be true because the shroud was never documented in possession of the French crown, and such a prized gift from a king to a nobleman would be highly unlikely. Since the time of its public presence in the 14th century, many have claimed to know the person who, quote, forged it, or heard that it was a forgery, though the accounts vary in name and age by hundreds of years, so no one has ever stepped forward to claim the masterpiece for themselves. In 1988, 3 samples were taken from the edge of the shroud adjacent to the left foot near the ventral image for carbon-14 radiometric dating by 3 independent labs. The collective date range they returned was 1260 to 1390 AD. On account of lack of documented history prior to the 14th century, combined with a carbon-14 date placing it solidly in the 14th century, most people believe the shroud to be a clever medieval forgery, and therefore consider the case to be closed. For most of my life, I too believed the shroud to be a medieval forgery, but I'm not really one to accept the claims of others simply on blind faith, so I decided to dig into that belief for myself. I realized I had absolutely no idea what the scientific evidence actually says, or what the Shroud of Turin Research Project actually discovered in their time with the shroud. I realized I had no idea what medium would have been used by the medieval artist, or whether or not we could even recreate it today. For those of you like me, what follows is the evidence that changed my mind and convinced me that the Shroud of Turin is indeed the authentic burial cloth of Jesus, and not at all compatible with the medieval forgery hypothesis. I hope you'll join me on my journey. Before we dig into the evidence, I need to offer some clarity on the fabrics in the Passion narrative. I've come to realize that many Christians read John's account of the burial preparation and assume that Jesus must have been wrapped up like a mummy. And since that assumption does not align with the idea of a burial shroud, these Christians automatically assume that the shroud is fake because it, quote, disagrees with the Word of God. So to better understand how the shroud fits into the gospel narratives, we need to take a closer look at the relevant verses. So let's start with the Synoptic Gospels. In Matthew 27, he indicates that Jesus is wrapped in a linen shroud. The Greek word here is sindon, which by definition is a fine linen cloth, or particularly a shroud. In Mark 15, he also indicates that Jesus is wrapped in a shroud, again using the same Greek word sindon. And in Luke 23, he follows suit with the wrapping in a shroud, also using the same Greek word sindon. So all three Synoptic Gospels are consistent in their indication that Jesus was buried and wrapped in a sindon, or a shroud. So then let's take a closer look at John's passage. When John says Jesus was wound in linen clothes, the Greek word that he's using is othonion, which in the plural refers to strips of linen. Now clearly, if these are intended to describe the same piece of fabric as the sindon in the Synoptic Gospels, then we have some sort of contradiction. But before we can draw that conclusion, we need to better understand what is being done with the fabric in each account, so as to shed light on exactly what is being described. Again, let's start with the Synoptics. All three verses translate the action to the English word wrapped, and both Matthew and Luke use the same Greek verb, entylisso, which means to roll in or to wrap in. This verb appears only one other time in the New Testament, in John chapter 20, when he describes the face cloth, or some translations call this the napkin, being folded up in a place by itself. So we can think of this verb as folding something up inside a piece of fabric, like folding a napkin over a dinner fork. The verb used in Mark is eneleo, and while it's unique to the New Testament, it has almost the exact same meaning. We can think of this application as rolling something up inside of a rug. Now let's look at John. The Greek word for wound here in John chapter 19 is deo, which means to bind, tie, or to fasten. There are many instances of this verb in the New Testament, so we can get a very clear picture of what it's intended to convey. In Matthew chapter 12, Jesus describes having to bind up a strong man if he wanted to plunder his house. In Matthew chapter 13, Jesus describes the picking of weeds and bundling them to be burned. In Matthew 27, Jesus is bound as he is carried away as a prisoner. And even in John chapter 11, we see Lazarus' hands and feet bound as he comes out of the grave. So in the Synoptics, we see an entirely different description than that told by John. The Synoptics tell of Jesus being folded up or wrapped up in a shroud, while John tells of Jesus being bound or tied with linen strips. So it's clear that these are not at all describing the same events, which means that these are not describing the same fabrics. The Synoptics are describing Jesus being wrapped up in a shroud, folded up like a fork inside of a dinner napkin, and John is describing Jesus being bound up with strips of linen. This would have been a quick and effective way of combating rigor mortis and keeping the shroud in place for a quick burial until they could return to the tomb after the Sabbath had ended. So let's do a quick summary of the Passion fabrics. First, we have the shroud. This is the Greek word sindon, and it's used consistently across all three Synoptic Gospels. Next, we have the linen strips. This is the Greek word othonion, and appears in John's account of not only the burial, but also the resurrection, where we find them laying on the floor of the tomb. And here in John chapter 20, we also see the only reference to the third fabric in the Passion, the face cloth. This face cloth is the Greek word sudarion, which is kind of a handkerchief or a napkin or a small towel. The only other occurrence of this word comes to us from John chapter 11 in the account of Lazarus, where his face is wrapped up in a sudarion. This confirms for us that, as it pertains to burial, a sudarion was used to wrap around the face of the deceased. So in the Passion narrative, we find clear references to three different pieces of fabric. We don't really know what happened to the linen strips after they were discovered on the floor of the tomb. But as we will see, we have very good reason to believe that the Sindon is the Shroud of Turin, and that the Sudarium is the Sudarium of Oviedo. So a proper exegetical study of the text is actually perfectly consistent with the Shroud of Turin, and in fact is not consistent with the mummy concept, as some might believe. Now, before digging into the actual evidence, we should first demonstrate that the shroud is consistent with all of the necessary criteria in the biblical account of Jesus' crucifixion. We'll start with the clothing. According to all 4 gospel accounts, Jesus was stripped, and the soldiers dispersed his clothes among themselves. We can therefore conclude that Jesus was naked during his crucifixion. Looking at the image on the shroud, we see no shirt, pants, tunic, or loincloth. And the backside from glutes all the way down to the calves are clearly visible and defined. Therefore, the shroud is consistent with this detail. 3 of the 4 Gospels attest to Jesus being flogged or scourged by Pontius Pilate. The Roman tool for this kind of punishment was the flagrum, a 3-stranded whip with lead balls in the shape of dumbbells. If we look at the back of the man in the shroud, we see cuts all the way down the back, angled in 2 different directions as if coming from 2 different points of origin, and we can clearly see the dumbbell shape in many of the cuts. The cuts continue down the backside, where we can clearly see the dumbbell-shaped cuts in the glutes, all the way down the legs to the calves. Therefore, the shroud is consistent with this detail as well. 3 of the 4 Gospels attest to Jesus having a crown made of thorns being placed on his head. Since the shroud image contains both the front and back sides of a man, we can observe that there are in fact blood flows originating from wounds all around the crown of the scalp. Therefore, the shroud is consistent with this detail. 3 of the 4 Gospels tell of how Jesus was struck, slapped, and beat in the face multiple times. Such a beating should have left its mark on the face. And in fact, we do see signs of such trauma. For example, one cheek is elevated, one eyebrow is elevated, and the nose and one nostril are enlarged and swollen. Therefore, the shroud is consistent with this detail. John confirms for us that Jesus' legs were not broken. The cause of death in the practice of Roman crucifixion was actually asphyxiation. By breaking the legs, the victim could no longer lift himself up to allow the diaphragm to expand and contract, and he would stop breathing and suffocate to death. However, John tells us that Jesus died quickly enough that they didn't break his legs, and the image of the man in the shroud is consistent with this detail. From Luke and John, we discover that Jesus was crucified with nails, definitely in his hands, and for assumed consistency, also in the feet. We also learn that Jesus was pierced in the side after death by a Roman spear. The shroud shows clear puncture wounds at the wrist and corresponding blood flows all the way down the forearms. Additionally, there's a clear puncture wound in the center of one of the feet. Finally, upon inspection of the torso, there's a large blood flow coming from the side of the torso. Therefore, the shroud is consistent with all of the piercing details. So let's summarize the contents of the shroud. The man in the shroud has no clothing. The man in the shroud was flogged and scourged consistently with 1st century Roman practices. The man in the shroud has wounds on the crown of his head consistent with a crown of thorns. The man on the shroud shows signs of physical trauma to the face. The man on the shroud did not have his legs broken. And the man on the shroud shows signs of puncture wounds consistent with nails in the wrists and feet, and a large puncture mid-torso. So clearly the contents of the shroud appear to meet all of the necessary criteria of the Bible. But does it pass the test of a professional forensic pathologist? According to Robert Buckland, world-renowned forensic pathologist and medical examiner, and the former deputy coroner of Los Angeles and Las Vegas, the left leg was rotated so that the left foot was placed on top of the right foot, a position maintained by the effects of rigor mortis. And based on the flexion of the left leg and the position of the left foot, he ascertained that the source of the puncture wound in the right foot would have penetrated both feet simultaneously. Furthermore, to account for the direction of blood flow, the forearms would have been outstretched at an angle of 65 degrees with the horizontal during the time of death. Buckland makes an interesting observation in the lack of thumbs in the image, and attributes it to muscle flexion due to nerve damage from the projectile which penetrated at the wrists. Moving to the torso puncture wound, he observes the presence of an additional water-like fluid among the blood stain, and also highlights the lack of splatter on the skin, concluding that this was a post-mortem puncture of a major arterial or organ source. And finally, he notes the abrasion and the softening of the skin and blood stains around the shoulders, consistent with the shouldering of a heavy object after the scourging. So not only is the image superficially in alignment with the biblical account, the expert witness of a professional forensic pathologist illuminates that the man in the shroud had developed rigor mortis prior to wrapping, that the forearm blood flow was consistent with outstretched arms, that the thumbs were flexed due to nerve damage from puncture at the wrist, that the mid-torso blood flow was post-mortem and originated from a major artery or organ, and that the man carried a heavy load on his shoulders after the initial scourging. All of these details only further expand on the correlation between the content of the shroud and the biblical passion narrative. One final point of interest. In every single medieval painting of Jesus' crucifixion, the nails are always in the center of the palm. Yet we know now, based on the physical structure of the bones in the hand, that a nail in that location would simply rip out through the fingers. It would not sufficiently carry the weight of the crucifixion victim. Interestingly, the shroud is different from every piece of medieval artwork in this detail, in that it places the nails at the wrist. Not only is this different, but it's also physiologically possible. That means that the shroud is more medically and physiologically accurate than every piece of medieval crucifixion artwork. So is the content of the shroud consistent with the biblical passion narrative? Absolutely. Alright, let's begin our investigation by looking at how the image was formed on the shroud. The image is not created by any paint, stain, or dye. It's not due to oil or bodily composition. It's not caused by acid, powder, or heat. Interestingly, there's no material, whether organic or inorganic, deposited on the shroud to form the image. The image does not crack at the fold lines, and there's no difference in spatial distribution when viewing the image in the infrared spectrum and compared with the visible spectrum, a feature present in brushed paintings. Also, if we look closely at the threads of the shroud themselves, we observe an interesting phenomenon. Each thread consists of many microscopic fibrils, and in the blood-stained areas of the shroud, the blood wicks through all of the fibrils by capillary action, meaning we can see the bloodstains on the back of the shroud. However, the image is present only on the topmost fibrils, indicating a lack of capillary action. And this is interesting because it is not physically possible to apply any sort of liquid, paint, stain, or dye to the shroud without it wicking through to the backside through capillary action. So we know for certain that the image could not have been formed through any sort of liquid applied to the surface. One final interesting observation: darker areas in the image are not formed by fibrils darkened to a greater extent. Rather, darker areas appear darker because of an increased density of darkened fibrils, and all of the darkened fibrils on the shroud are darkened to the same extent. This means that the fibril darkening cannot be attributed to an extended exposure process like heat or sun bleaching. Such a process would cause fibrils to darken proportionally to the time over which the process was applied, which means lighter areas of the image would contain lighter fibrils, and darker areas of the image would contain darker fibrils, which is not consistent with the data observed in the shroud. So then, what does cause the image to appear on the surface of the shroud? The fibrils are darkened because the cellulose molecules in the flax fibrils have been chemically altered. There are carbon atoms in the cellulose molecule which, under normal circumstances, share a single electron bond, but the darkened fibrils contain cellulose molecules in which the carbon atoms have a double electron bond. The question is, what can produce the net effect of the image of the shroud? We've experimentally determined that heat can induce the molecular change in the flax fibrils. However, heat cannot create shaded regions with an equal extent of fibril change, and it cannot create a 3D depth map unless we change some fibrils more than others. There's a theory out there called the shadow shroud, which posits an inverted painting on glass that the sun could bleach areas of the shroud lighter than others, effectively creating the 3D depth map of light and dark. But while sun bleaching could induce a molecular change in the fibrils, it wouldn't be the same since the darkened fibrils would be unchanged while the lighter ones would be chemically modified. Also, it could not induce the same extent of molecular change as those areas bleached lighter would have fibrils modified to a greater extent than those that are less bleached. In fact, so far, the only one process which has been able to produce all of the chemical effects of the fibrils and result in a 3D depth map of a man on the linen is radiation. But if radiation is in fact the best explanation for how the image was formed, that raises some big questions for both major hypotheses. We have absolutely no idea how a medieval artist could have used a controlled radiation source to create the image in the shroud. In fact, do we even possess this ability today? No, we don't. The previously cited result comes from simulation only, because even with our advanced technology today, we cannot reproduce the image with all of the same chemical effects we observe in the shroud. But for those who claim authenticity, why would we believe that a human body could emit radiation? Do we have any scientific evidence of a body emitting radiation? Surprisingly, we do. In 2018, we captured for the first time the radiation of zinc molecules from a human egg through the natural processes at the moment of fertilization. This result doesn't necessarily mean that we can say for certain that Jesus' body emitted some sort of particle radiation while wrapped in the shroud, but it certainly makes it physically and scientifically possible. So based on all of the scientific evidence gathered from the shroud, we can with a high level of confidence assert that radiation was the mechanism that formed the image. Next, we'll look at the blood-stained regions on the shroud to see exactly what they're made of. The bloodstains contain heme derivatives, bilirubin, albumin, serum albumin, iron, and protein content. They contain both X and Y chromosomes and hemoglobin DNA. Recent research has also located the presence of creatinine in the blood regions. So then what can we conclude? The bloodstains are caused by actual blood. Some skeptics have tried to posit the use of a medieval paint derived from iron and vermilion, which might be able to explain some of the chemical results. However, such a paint would not have serum albumin, X and Y chromosomes, nor hemoglobin DNA, which is an informational molecule. Additionally, since iron is a heavy metal, it would appear differently under X-ray than areas outside of the bloodstains. But that's not the case. Bloodstain regions are indistinguishable from non-bloodstain regions under X-ray analysis. So we can confidently conclude that this medieval paint does not explain all the evidence. Others have accepted the presence of blood and simply posit a theory that the artist painted with blood. The first problem with this theory is that there are no brush strokes on the shroud anywhere. Also, serum albumin is involved in clotting of blood. So the blood on the shroud was either clotting or already clotted, which means it won't flow very easily. We also know that bilirubin is formed when old or damaged red blood cells are broken down, which means that the source of the blood had excessive damage to its red blood cells, as would be the case in severe wounds. And creatinine is also found in the blood of trauma victims, meaning the source of the blood had undergone severe physical trauma. But the most damaging piece of evidence to this hypothesis is that the cross-contamination antigen response of the blood does not match any known species of animal in existence. That means that the artist couldn't have simply used a common animal like a dog or a pig as the source of the blood. However, the closest antigen profile is that of human type AB blood, which means that the source of the blood was closer to human type AB blood than any other known species in existence. So then, if the bloodstains are made from genuine blood, what does that mean for our two main hypotheses? For the medieval forgery hypothesis to hold water, we must assume that an artist used the blood of a male organism from some unknown but almost human species with type AB blood, who had undergone intense trauma and suffered severe wounds. We must assume that the artist allowed the blood to begin clotting and then applied it to the shroud without the use of a brush. However, the authentic hypothesis is significantly less ad hoc, since the presence of blood from a trauma victim with many wounds is completely consistent with Jesus' crucifixion. And if Jesus were conceived miraculously, as is described in the Bible, it would completely explain why his DNA and associated blood would respond to cross-contamination in a way almost identically to, but not quite the same as a typical human. So then, based on all of the scientific evidence, what can we conclude about the bloodstain regions on the shroud? They're the result of clotting or clotted blood from a tortured, traumatized, almost human male organism. In addition to the molecular structure of the fibrils and the contents of the blood stains, there are numerous other pieces of physical evidence on or within the shroud which directly contradict the medieval origin hypothesis. For example, the spinning wheel had become a standard piece of equipment in Europe by the 13th century. However, the threads on the shroud were not produced on the spinning wheel. They are hand spun. In addition, the 3-to-1 herringbone weave was not being produced in medieval Europe and is much more common in ancient Syria. As mentioned earlier, the shroud's approximately 14.5 feet long by 3.5 feet wide. If we translate those dimensions into Roman cubits, the standard unit of measure in medieval Europe, the shroud is about 10.6 by 2.6 Roman cubits. But if we translate it into Assyrian cubits, the standard unit of measure in 1st century Judea, the shroud is almost exactly 8 by 2 Assyrian cubits. Though it's somewhat circumstantial, it seems unlikely that a piece of fabric would be sold at fractional standard market dimensions, especially since there's a side strip sewn onto the side of the shroud to make it the proper width. It seems much more likely that the fabric was sold in a market that used the Assyrian cubit for its standard unit of measure. Interestingly, the stitch used to sew the side strip onto the shroud is very unique historically. It has only been found in textiles from one other place in history, the ancient city of Masada, which was a Jewish city destroyed in 73 AD and never reoccupied. So from a historical analysis, the manufacturing method of the thread, the weave of the linen, the fabric dimensions, and the stitch of the side strip are all incompatible with the medieval origin, yet align perfectly with the 1st century Judean origin. At a microscopic level, we find cotton fibers among the linen threads, specifically a cotton species called Gossypium herbaceum. This particular species of cotton does not grow in Europe, but rather in the Middle East and Africa. In addition, there are limestone particles on the shroud, especially around the area of the feet. The spectral signature of these limestone particles is not consistent with that found in Europe, but perfectly matches the samples taken from Jerusalem. Pollen evidence is also of significant interest, as there are 58 species of pollen found on the shroud. However, only 17 of those 58 species actually grow in Europe. The remaining 41 species of pollen do not grow in Europe at all, but rather in Africa, Asia, and the Middle East. In fact, of the 58 species of pollen on the shroud, 55 of them grow in Jerusalem. And only 3 species of pollen do not grow in either Europe or Jerusalem. Those 3 species of pollen are local to regions of Urfa, which used to be called Edessa, and Constantinople. In fact, of the 58 species of pollen on the shroud, 18 of them grow in Urfa or Edessa, and 13 of them grow in Constantinople. So with 58 species of pollen on the shroud, there are many species local to Jerusalem, Edessa, and Constantinople, in addition to the European species of pollen. If the fabric had originated in Europe and remained in France for the entirety of its existence, there's absolutely no way to explain the presence of so many species of non-European pollen. There's also a species of pollen of particular interest, called Gundelia. This pollen, which was found in very large amounts on the shroud, is a thistle local to the Middle East, which has very long thorns on it. So from microscopic analysis, the Middle Eastern cotton in the flax fibers, the Jerusalem limestone, the 41 species of non-European pollen are all incompatible with the medieval origin, yet align perfectly with a 1st century Judean origin. While carbon dating is the gold standard, there are certain physical properties of the shroud material that can assist in the discovery of the age of the fabric. As a review, the carbon dating puts the shroud between 1260 and 1390 AD. Yet there are 2 flax spectroscopy tests which are used to determine the age of flax fibers themselves. And these 2 tests say that the flax fibers are from anywhere between 700 BC and 300 AD. And an additional test of the tensile strength of flax fibers indicates that the fibers originated between 0 and 800 AD. Plus, a test of a material aging due to ambient environmental factors puts the flax fibers at about the same age as the Dead Sea Scrolls, which originated between 250 BC and 70 AD. So by employing additional methods of aging flax fibers, we can find that the 2 spectroscopy tests, the tensile strength test and the environmental damage test, are all incompatible with the medieval European origin, yet align perfectly with the 1st century Judean origin. So let's summarize the physical evidence. When we evaluate the manufacturing of the thread, the linen weave, the physical dimensions, the side strip stitch, the cotton fibers in the thread, the pollen species on the shroud, the limestone particles on the shroud, and the 4 additional means of aging flax fibers, we find that not a single piece of physical evidence is consistent with the medieval European origin. Yet, every single piece of evidence aligns perfectly with a 1st century Judean origin, which means that the physical evidence deposited on the shroud is completely incompatible with the medieval forgery hypothesis, and instead points exclusively to the authenticity of the shroud. As I discussed earlier, there were 3 pieces of fabric in the Passion story: the Sindon, the Othonion, and the Sudarion. The last one, if you recall from John chapter 20, was a napkin or a face cloth that was used to wrap the face of Jesus and was found in the tomb on that Resurrection Sunday. We have actually very good reason to believe that the Sudarium of Oviedo is that Sudarion. The Sudarium of Oviedo actually has a very well documented paper trail. It was in Judea until 614 AD when it was taken to Alexandria by a presbyter named Philip, ahead of the Persian conquest of Jerusalem. Then just 2 years later, as Persia continued south in their conquest, the Sudarium was taken across North Africa as Persia continued to expand its empire. The Sudarium fled to Spain among the refugees, entering at Cartagena. It spent the next 100 years in Seville and Toledo, and then in 718 AD it entered the region of Oviedo, and it's still housed in a church in Oviedo today. Since the Sudarium doesn't have an image on it, and there's no interruption of the image around the head and the shroud, it must be true that the Sudarium was not on the body at the time of Jesus' burial, which has led some to question why it would be in the tomb at all. So to quickly answer that, let's review the code of Jewish law, which declares that the final blood coming from the body at the moment of death is considered the, quote, lifeblood. And according to this code, anything which contains the lifeblood should be buried with the body, so as not to separate the body from the lifeblood. So according to the contemporary Jewish law, the Sudarium, which likely covered Jesus' head while he was being removed from the cross, evidence of which we'll discuss in a minute, would have wiped some of the blood from Jesus' body and would have therefore been considered a carrier of lifeblood. And that's precisely why we should expect the Sudarium to be in the tomb, even if separate from the body and the shroud. So let's dig into the evidence discovered under scientific investigation of the Sudarium. First, there's a significant amount of dirt and pollen on the Sudarium. Dirt samples and pollen species match those sampled from Judea, North Africa, and Spain, supporting the documented paper trail of the Sudarium. In fact, the dirt matches samples taken specifically from the area around Calvary, where Jesus was crucified. Interestingly, the Siderium contains a large amount of pollen from the Gundelia thistle, the same thorn-bearing Middle Eastern thistle found on the shroud. It also contains stains of both blood and fluid in a ratio of 1:6. Though a full species analysis has not been performed on the blood is or very closely matches human type AB blood, the same as found on the shroud. The fluid is pleural edema, a fluid that develops in the lungs of those who die of asphyxiation. When the body is jolted, this fluid can come out of the nostrils. Furthermore, the fluid stains show signs of drying between additional fluid discharges, meaning the body underwent multiple rounds of movement after the Siderium had wrapped the head. Based on this evidence, forensic analysis has concluded that the Siderium of Oviedo wrapped the head of a person who died of asphyxiation. Additional analysis of the stain patterns indicate that the person died in the upright position with his head tilted 70 degrees forward and 20 degrees toward the right shoulder. And the person's nose was 8 centimeters long, which happens to be identical to the shroud. And the blood points originated at the exact same locations as on the shroud. So, if we do a quick summary of the comparison between the Siderium and the shroud, we find that the blood type is identical, the facial geometry is nearly identical, and the blood origin points are identical. They both contain significant amounts of dirt and pollen from non-European locations, and we know that the evidence corresponds perfectly to the documented Siderium paper trail. They both contain significant amounts of pollen from the thorn-bearing Middle Eastern Gundelia thistle, and they both show forensic evidence of a death consistent with the Roman practice of crucifixion. In fact, the one and only data point that conflicts between the shroud and the Siderium is the carbon dating, which places the Siderium around 700 AD, some 600 years earlier than the shroud. So, based on the scientific and historical evidence, the Siderium of Oviedo is very tightly coupled to the Shroud of Turin on everything except the carbon dating. One interesting fact that many are willing to simply overlook is that 700 AD postdates the known history of the Siderium by nearly 100 years. By 700 AD, the Siderium was in Spain, yet the physical evidence deposited on the Siderium clearly indicates that it spent significant time in the Middle East. So then, what we've seen so far is that every bit of scientific evidence and historical evidence on both the Shroud of Turin and the Siderium of Oviedo points to the authenticity of both artifacts, all with the exception of the carbon dating. Additionally, carbon dating is the only piece of discrepancy between the two artifacts, which are otherwise very tightly coupled by the physical evidence. And the carbon dating of the Siderium postdates its known documented history, which is corroborated by pollen and dirt evidence by at least 100 years. So it's time to address the elephant in the room, the carbon dating. To understand what's ahead, you'll need to first understand how carbon dating works. So let's have a quick science lesson. Carbon, if you recall from high school chemistry, has an atomic number of 6, which means it has 6 protons in the nucleus. Under normal neutral charge conditions, carbon also has 6 electrons orbiting the nucleus, balancing out the charge of the protons. And in its most common state, carbon atoms contain 6 neutrons in the nucleus. Since there are 6 protons and 6 neutrons for a total of 12 subatomic particles in the nucleus, this form of carbon is known as carbon-12, and since it's charge neutral, it's also very stable. Now, if we were to add another proton to the nucleus, then we'd change the atomic number, which creates a new element, in this case nitrogen. But if we were to add another neutron to the nucleus, then we would form what's called an isotope of the current atom. One of the known carbon isotopes is carbon-14. 14 because it has 6 protons and 8 neutrons, for a total of 14 subatomic particles in the nucleus. And this particular isotope is not at all very stable. Over a certain amount of time, one of the neutrons will undergo beta decay, meaning it will change to a proton and kick out an electron. And since we now have 7 protons in the nucleus, and we have a new atomic number, and a new element, nitrogen. And this atom with 7 protons, 7 electrons, and 7 neutrons is very stable. So over time, these carbon-14 isotopes will decay into nitrogen-14 atoms, and that decay has a half-life of 5,730 years. If you don't recall, the term half-life basically means that half of a quantity of an element will be gone after the time has elapsed. So if you have a given quantity of carbon-14, half of it will be gone after 5,730 years. After another 5,730, half of the remainder will be gone. And again, and again. We can plot this exponential curve as a percentage remaining versus time. So if we take a sample and determine the percentage of carbon-14 lost, we can figure out the percent remaining. We find where that intersects the half-life curve and locate the x value of the intersection point to find the time elapsed. In this case, 1,984 years. But how do we find the percent of carbon-14 remaining in a sample? To answer that, we need to know how carbon-14 is formed. So here's the Sun and the Earth. When a cosmic ray enters our atmosphere, it interacts with particles there and creates a secondary cosmic ray in the form of an energized neutron. This neutron collides with the stable nitrogen-14 atoms in the atmosphere. The result of this reaction is the formation of a carbon-14 atom with 6 protons, 6 electrons, and 8 neutrons, and the ejection of a proton with no neutrons, or essentially a hydrogen atom. So we all know that carbon will react with oxygen and form carbon dioxide, and this carbon dioxide is absorbed by plant life during photosynthesis, resulting in the production of oxygen. And the carbon broken down from the CO2 is absorbed by the plant. Some of that carbon absorbed will be a stable carbon-12 isotope, and some of it will be other carbon isotopes, like carbon-14. Since carbon-14 production is based on natural processes in our atmosphere, the ratio of carbon-14 to carbon-12 atoms absorbed by the plant is, for all intents and purposes, constant. So the ratio of carbon-14 to carbon-12 is constant in the air, in the plants that absorb it from the air, in the animals that eat the plants, and in the animals that eat the animals that eat the plants. But when a plant dies or is harvested, it no longer absorbs new carbon. And when an animal dies, it no longer consumes sources of new carbon. And under normal conditions, the amount of carbon-12 in the object will remain constant, but the amount of carbon-14 atoms begins to decay with a half-life of 5,730 years. So if we take a sample of something, we can measure the number of carbon-12 atoms in it, represented by the variable m, and the number of carbon-14 atoms, represented by n. If we take our constant ratio of carbon-14 to carbon-12, and multiply that by the number of carbon-12 atoms in the sample, that will give us the initial number of carbon-14 atoms in the sample, represented by the variable k. By dividing our current number of carbon-14 atoms by the initial number, we arrive at the percent of carbon-14 remaining, which we can plug into our half-life formula to determine the time elapsed since the death of the plant or animal in question. So armed with this knowledge, let's take a look at the dating of the shroud. Recall the 3 independent labs measured samples from the shroud, and they each arrived at a certain percentage of carbon-14 remaining, correlated that to an elapsed time of around 600 to 730 years. This meant that the flax plant, which was used for the linen thread, was harvested somewhere between 1260 and 1390 AD. Likewise, with the cerium, a sample was taken, percentage of carbon-14 determined, and time elapsed was determined to be about 1,290 years. This meant that the flax plant, which was used for the linen thread, was harvested around 700 AD. So for those who hold to the medieval forgery hypothesis, the carbon dating results simply confirmed their existing beliefs. Case closed. And for those who held to the authenticity in the past, it posited various theories to explain the mismatched dating results. Some have claimed that the samples were tainted by various burns on the shroud or by exposure to church fires, which it had been stored in the past. Some have claimed that medieval fabric was sewn into the original shroud in a way that was overlooked by those taking the measurements. And some have even claimed that what was actually sampled was a patch from a medieval repair. But all of these theories have failed for one reason or another, and none of them are taken seriously by most scholars today. However, within the last 10 years, a new hypothesis has come into play, and one that ties all of these uncertainties together. To understand this new hypothesis, let's revisit the carbon dating on the shroud. In each of the 3 samples, the lab would have calculated the M and the N variables, then determined the initial quantity of carbon-14 in the shroud. And by dividing N by K, they get the percent remaining and calculated the elapsed time. But what happens if our initial carbon-14 calculation is actually not correct? What if instead of just being K, we have K prime atoms, which would be the theoretical K value plus some additional carbon-14 represented by Q? In this case, since K is not representative of the true initial quantity of carbon-14 atoms, our percent remaining is incorrect. To get a true percent remaining, we would need to be dividing our current quantity N by the true initial quantity K prime. So our graph would actually look something like this, where the incorrect curve, which doesn't take into account our additional carbon-14 atoms, is the dashed line, and our correct curve is the solid line. So we could then look at the percent remaining discovered by the 3 independent labs and see that while the dates calculated do cross the incorrect curve, those dates are not the correct intersection with the true curve. Rather, the true intersection point has a significantly longer time elapsed. This means that if the initial carbon-14 is actually higher than the theoretical K value, then a sample would actually be significantly older than the uncorrected calculation predicts. But why would we even consider this? Why think there would be additional carbon-14 atoms in the shroud? For that, we need to go back to how carbon-14 is created in our atmosphere. Recall that cosmic rays create energized neutrons, which react with the nitrogen-14 atoms to create a carbon-14 and a hydrogen atom. And recall that the leading scientific explanation of the image formation mechanism in the shroud is radiation. Now, radiation can be in the form of a wave, but it can also be in the form of energized particles, like neutrons. So in a human body about the size of the man of the shroud, there are 2 times 10 to the 28th neutrons. And if just 2 times 10 to the 18 of those, which is only 1/10 billionth of the available neutrons, were radiated from the body, it would react with enough nitrogen-14 atoms and produce enough carbon-14 atoms to make a 1st century piece of linen fabric look like it originated in the 14th century. Enter the neutron absorption hypothesis. This theory is put forth by Robert Rucker, a retired nuclear engineer who spent his entire career designing and simulating nuclear reactors and the associated radiation inherent in their design. For this hypothesis, he simulated a body wrapped in a linen shroud, placed in a tomb consistent with 1st century Jewish practices. Based on the composition of the body, he simulated the distribution of neutrons that would have been absorbed by the linen, and used that to calculate the effective carbon-14 date that would result on the shroud. This table is a top-down view of the tomb table and the side benches. First point of interest is that the calculated carbon-14 date near the feet does in fact show the dates in the 12th to 14th century time frame. Next point of interest is that at the center of mass, the calculated age would be thousands of years in the future because there was so much carbon-14 generated. This means that if the Vatican would let us carbon date a sample from the torso region, we could effectively further validate this hypothesis. Let's just hope that happens in the near future. Another interesting result from this simulation is that near the feet, there's a correlation between calculated age of the fabric and linear distance from the edge of the shroud. So Rucker went back and looked at the actual carbon-14 data from the 3 labs, which was only recently published. He noticed that the Oxford lab returned a 1200 AD result, Zurich returned a 1273 AD result, and Tucson returned a 1303 AD result. If we compute the difference between these results, we end up with an uncertainty of 102 years plus or minus 35 years, which equates to nearly a 3 sigma uncertainty. First of all, this is well beyond the maximum 2 sigma threshold accepted in most carbon-14 tests. But more importantly, Rucker noticed that there is indeed a positive correlation between the calculated dates and the distance of the samples from the edge of the fabric, consistent with his simulated results. Rucker also went back to look at the data to see if he could explain the dating of the Sudarium of Oviedo. As it turns out, there are bands along either side bench where if the sudarium were placed, it would date to around 700 AD. So all in all, Rucker's hypothesis can explain why the shroud dates to the 13th or 14th century, why the shroud carbon-14 data has such a large statistical variance, why there is a correlation between the calculated age and distance from the edge of the shroud, and why the shroud and the sudarium, which are so closely coupled in all the scientific evidence, date to nearly 600 years apart. And perhaps the most interesting of all is that Rucker's hypothesis is completely consistent with the leading scientific explanation and only known cause of the molecular change to the cellulose molecules in the flax fibers that form the image of the shroud. The medieval forgery hypothesis, however, has absolutely no answer to any of the above questions, and still does not address the myriad of scientific evidence pointing to the authenticity of the Shroud of Turin and the Sudarium of Oviedo. So why is the carbon-14 result on the shroud and the sudarium wrong? The most likely explanation is that energized neutrons radiated from the body, the same ones which cause the image to form through the molecular change in the cellulose molecules of the shroud, and they produced additional carbon-14 atoms in the fabrics, making them look significantly younger than they really are. So far, we've uncovered numerous scientific evidences which point to the authenticity of the Shroud of Turin. And we've presented the neutron absorption hypothesis, which rectifies all of the outlying carbon-14 data with the remainder of the physical evidence. All this to say, the case for authenticity is very strong, but the question on the shroud's location remains unknown. So let's dig into the historical record and see if we can find the Shroud of Turin before Geoffroy de Charnay in 1350.